Hey, welcome to D-Lab's Basic Training. Yes, sorry it's been a long time, but I've been pretty busy. Let's see what Fred Caddy has in store for us. Good old Rat Fink. It's always good to see him. So here we go. Today, we have a 5F1. This is a Fender clone kit, okay? The fault is noise and lots of vibration sensitivity. It crackles, all right? So 3 things to consider. Is it a tube? Is it a bad connection? Is it a poor build? Or are there Rice Krispies inside? So first, since we know the amplifier was up and running, we're going to go ahead and power it and perform a tap test and see if we can find the sensitive area. Then we shall do a visual inspection, and if we have to, we'll pull that eyelet board out and see what's on behind the scenes. Sounds good, eh? Alright, on the bench we have a Fender 5F1 kit. Complaint is it's extremely noisy and sensitive. Turn up the amp a little bit. You can hear the noise on the board. Not very sensitive on the tube sockets themselves, but the board, super sensitive. What I see is all the eyelet connections are corroded and the soldering is poor. The only way to correct this is to put in a new eyelet board. That's what we're going to do. Alright, I got the eyelet board out so you can take a closer look at the eyelet connections. You can see they're kind of corroded. The solder kind of pooled and sat on top of the eyelets. So trying to remove all that and clean those eyelets and get a good connection is probably not a good idea, but I think I found the main item here on the back side that was causing the sensitivity. See this jumper? That was probably it. And that's what happens when you simply take a wire and touch it and rely on the solder to make the mechanical connection. So I did post a short of this exact amplifier with the problem, and I received this comment. A fellow said, "I don't believe it's a mechanical connection issue. I think it's just a bad solder connection. After all, there's trillions of surface mount components out there and they never fail without having a mechanical connection." So then I thought to myself, after I complete my spin, how can we possibly compare surface mount components to 1960s vintage components? After all, if the eyelets were intended for the leads to touch them, they wouldn't be an eyelet, they'd be an iPad. Okay, we're getting pretty close to reassembling the champ. I added some number 6 standoffs to hold the board secure. Before, they had simply ran some sheet metal screws through into the chassis. I really didn't like that. We want this new board to be mounted professionally. Also, I removed this goofy ground terminal board that was stuck way down here in the corner on one of the lugs of the power transformer. I installed a 5-position terminal board. This will land the filaments, the balancing resistors, and grounds. Okay, we're ready for final wiring. I've got my AC line coming into the terminal board. This is my filament circuit with the balancing resistors. So I'm going to be swinging over my filament supply off that terminal board, and it'll also go to the front dial lamp. I've color coded the wiring on the eyelet board for easy hookup. We're ready to go. Rebuilding of the 5F1 is complete. I installed some nice new Switchcraft jacks, of course the F&T filter caps, Jupiter coupling caps, and rewired the AC input using the terminal board. So she looks really nice. Let's see how it sounds. Alright, let's take a listen to the little 5F1 champ after repair. I have it on, the volume is all the way down. No hum. The volume all the way up. Hook up the looper. Well, here's another track on the looper. This time I'm in channel 1, so we get quite a bit more gain. So the rebuild of the 5F1 was definitely the best route to go. Trying to repair that would have been a real pain in the keister. So in conclusion, obviously the fault here was a poor build, bad solder connections, and other issues that didn't even agree with the instructions from the manufacturer.